So, hi everyone. So today we are going to talk about how you can use AWS RoboMaker and SageMaker to build reinforcement learning applications. We'll take an example and try to explain step by step how you could use these two services to build similar applications. So how many of you are familiar with AWS RoboMaker? Okay. Okay. So for people who do not know about AWS RoboMaker, it's a new service that we launched a couple of days ago, which is focused on, which is a one-stop store to build robotics applications. So we have 4 different offerings. The first one is the development environment. So we provide a development environment where you can go. We are tightly integrated with Cloud9. So you can go to this cloud-based development environment and develop your robotics application. We have deep integration into Cloud9. So you can directly build your robotic application from the Cloud9 IDE, bundle it, and start a simulation. So few of you would be asking, like, why do I need a simulation? So testing a simulation, testing a robotics software is very difficult. Things are not deterministic in the real world. So the best way to test a robotic application is to simulate it in a world that is close to the real world and see if it does what it is supposed to do. So we provide a simulation service where you can go and simulate your robotic software. So once you have simulated it, and you are happy that your robot does what it's supposed to do, we have a fleet management service where in a single click, you can go and deploy your robotic software to a fleet of robots. The fourth thing that we offer is cloud integration. So we provide packages that you can use out of the box, which you could use in your robotic software to integrate with other AWS services like CloudWatch. So one of the biggest asks from our customers were, the biggest problem in the robot is the battery. It goes down very slow. So they want to monitor their batteries. So using the packages, using the cloud integration packages that we provide out of the box, you can integrate with CloudWatch and upload your metrics off to CloudWatch, where you can monitor the battery status of the robot and things like that. We have integration with Kinesis Video and other AWS services. So before going any further, I would let Saurav explain what is reinforcement learning. Go ahead.
Yeah. So I'm going to give a very high-level overview of how reinforcement learning works. So in this image, let's say that this is the simulator, which is RoboMaker. So we have an agent, a reinforcement learning agent, which interacts with its environment. So how it interacts, it takes in the state. So state is image in this case. And it outputs an action, and then it takes an action on the environment. So this is a car, so action here can mean steer right, steer left, or go straight. And whenever it takes an action, it gets a reward from the environment. Now we can design this reward function, and for the actions that we want to, for the good actions that the agent takes, we can give it positive reward, and for the bad actions, for example, going off track, we can give it negative reward and discourage those actions. Now, how the training works. So we have the simulation running in RoboMaker, where the agent generates these sets of experiences. And by experiences, I mean the state, the current state in which the agent is, the action it took, the next state, and the reward it got. So this tuple of 4 elements is an experience. And here what it does is RoboMaker collects these experiences and sends it to SageMaker. Now, SageMaker has the model, and the model is nothing but just a neural network which takes in the images and outputs an action. So SageMaker trains this model. It collects these experiences. Experiences become the training data for the SageMaker neural network, and it sends the updated model back to RoboMaker. So for example, in this image, we have 2 instances of simulations running. Both of these get new updated models, and then they generate the next set of experiences. So this training loop keeps going on until the model converges. And what I mean by converges is that in this case, the car learns to drive in the center of the track.
Sure. So awesome. So now I think most of you know about RoboMaker and what reinforcement learning is and how it can be used to solve some important problems. So if you want to use reinforcement learning, RoboMaker provides sample applications which you could use out of the box in a single click start a reinforcement learning application. So how many of you are familiar with Deep Racer or the RoboRally? So the RoboRally the Deep Racer service is built on top of RoboMaker and SageMaker, where it uses RoboMaker for simulation and SageMaker for machine learning. And we are not here going to talk about Deep Racer. Everybody knows about it. So the problem that we are going to solve over here is how we can teach a robot to follow another robot. So with us, we have two robots. One is called a waffle. The other one is called a burger. And we'll see how waffle learns in a simulation to follow burger. So if you want to try it out, we have a sample application in the RoboMaker console where you can go and say that I want to try out this example where the robot learns to follow an object, and click launch to start that. Behind the scene, RoboMaker is going to start the simulation for you where the reinforcement learning is going to run. Here, the reinforcement learning runs on RoboMaker itself, or the algorithm runs on RoboMaker itself. As you could have, so we need to wait a couple of minutes. So here, behind the scene, what's happening is RoboMaker uses CloudFormation to start up all the things that are needed for you, that is needed to start this particular example. I have one started for you. So I'll quickly go to to look at one of the simulations that I started earlier. So using RoboMaker, you can go to the simulation and use various tools that are provided to observe your simulation. So we have tools like Gazebo, which you could use to see what the robots are doing. So let me make it big. Awesome. So here you're seeing that this robot, Waffle, is learning by trial and error to come close to Burger. And it takes several hours to learn to train on top of RoboMaker. So there are other tools in RoboMaker which you could use to inspect how the training and the simulation is going on. As you could have figured out, this is too slow. So Saurabh is going to tell you how you could make this process much faster.
OK. So the workflow Gaurav just described does the training and simulation both on the RoboMaker instance. Now, let's say we want to speed up the training process, and we want to use SageMaker for training and use multiple simulators. So the way we can do it is we first have to go to the SageMaker console. And how many of you are familiar with using notebook instances on SageMaker? OK. So what we do is we go to SageMaker console, we go to notebook instances, and we create a new notebook instance. So we can just give it any name. We select the instance type. And the rest of the things we can leave as defaults. And then we just go and hit create a new notebook instance. So this takes around 5 minutes. I already have a notebook instance that is up and running. So once I click Open Jupyter, I'll be shown an interface like this. So this happens when I click Open Jupyter Notebook. And then what I have to do is I have to go to SageMaker examples. I have to go to reinforcement learning. And then we have where is it? Yeah. So this is the example we are looking for. So this object tracker, coach, and RoboMaker. So if I click on use, then the notebook will get opened. So I already have an open notebook here. Yeah. So all we have to do is just execute these notebook cells in sequence to start the SageMaker and RoboMaker job. So most of this code is boilerplate code. It just imports the relevant dependencies. It sets the S3 bucket, defines some job-related variables. So the parameters which are of interest to us are defined in this Python file, which is objecttracker.py. And this defines the reinforcement learning algorithm that we want to use. So here we are using a state-of-the-art algorithm, which is known as clipped PPO. And we define all the learning parameters here. So we have learning rate, batch size, which optimizer, and so on. And once we have those things, we can just kick off a SageMaker training job. So the main parameters here are, again, the instance type. So we can use a GPU instance if we want the training to be even faster. And that's mostly it. So S3 bucket, S3 prefix, we defined all these variables before. And on running this cell, the SageMaker job will start. So now once the SageMaker job is up, our next step is to start the RoboMaker job, which we do by executing these cells. So again, all these steps, most of these steps are just required to be executed once when you run these jobs for the first time. So for example, you have to create a simulation application. Again, there are no parameters that you have to change here. Everything that is set to default will work well. In the cell, you create a simulation application. And then in the next cell, you launch the RoboMaker job. So here, this is an important parameter where you can set the number of simulation workers. So in this case, it's 2, which means that it will start 2 RoboMaker simulations. Both of these simulations will connect to the same SageMaker training job. It will send the training data to SageMaker. SageMaker will train the model, upload it to S3. And finally, RoboMaker will again download this model from S3 and use it to execute the next sequence of episodes. That is generating more training data set for the training process. So this process goes on in loop once we get convergence, which means our model has learned what it was supposed to learn. So on executing this cell, we get links to these 2 simulations. So let me open simulation 1. So this points us to the RoboMaker console. And here we can visualize what's going on. OK.
Finally.
Here we have it. And again, this is similar to what Gaurav just showed. So let's wait for the second bot to come.
You can.
OK. Where's the bot? Oh, so this happens when SageMaker is training the model. So right now, what's happening is the simulation is paused because it's waiting for a new model from SageMaker. So once SageMaker pushes a new model to S3, it will download the new model, and then it will start the simulation again. So this usually takes a couple of seconds. It can take around 20, 30 seconds. I think meanwhile, we can look at the second simulation that's there. OK, the second bot is missing. OK, it's here. Yeah. Yeah. So as you can see, what's happening here is the bigger robot is trying to go closer to the smaller bot. And it's getting rewards on the basis of how good it's doing from the environment itself. So if it's taking a lot of steps and still not being able to go to the smaller bot, then it gets a highly negative reward. And all the sequence of actions that it followed, they are discouraged. So this is taken care of in training. Now, there are some good episodes where it goes to the smaller bot in a smaller number of steps. And the actions that it took in those episodes, they are encouraged because it did the right thing. And this is how the training and the simulation loop work.
Awesome. So what we saw over here is that um, using a simple reward function that was behind the scene, the reward function in this case, so before reward function, so for the reinforcement learning to work, you provide something called as a reward function, which is a function that gives points to the robot when it takes some action. So here, the reward function is as simple as give it more points if it gets closer to the smaller bot. And this is so simple, so elegant, and so powerful. And using multiple simulations in parallel, you can quickly teach a bot to do anything that you want. So using RoboMaker, coming back to RoboMaker, so connecting all the dots. So we started with the single machine training, where we used RoboMaker for doing simulation and training as well, and we saw the problems. It was slow, so we moved over to a distributed architecture where we used RoboMaker and SageMaker both together, where SageMaker was doing training and RoboMaker was doing simulation. And the training became fast because you could use GPU instances on SageMaker, right? And apart from that, the way we have designed the system, you could use multiple simulations together to do the training, which even makes it even more faster. Then the models that are generated during the training are written to S3. You could use RoboMaker to go and deploy those models to the physical robots. So we have the third offering, as we discussed, was a fleet management service which you could use to deploy the models to a robot. So actually, the texture of the floor here is not good. We would have loved to show you the exact robot doing it over the stage. But I have some videos for you guys that I can show you where we tried and tested this model that was developed using RoboMaker and SageMaker by deploying it onto an actual robot. So the first video that I want to show is, so right now there is Waffle, and Waffle is trying to look for a burger, and it is not finding it, so it's just going around. OK? So just to show that I am not cheating, this guy is taking random things, right? So let's put a burger out there. So now we have a burger at the corner, and you see a Waffle on the left, and you'll see how Waffle finds it and then moves towards it. So there is no hard coding. There's nothing deterministic in there running. So there's a machine learning model that is taking the action that has learned during simulation. So we taught it to do this during simulation, but this model generalized so well that it was able to even follow a Waffle. So, however, one thing that we learned, you see that there is a white background, and you can see that I brought white paper with me to show the demo, because these things are very sensitive to the environment. And there's where the power of cloud comes to. So you can run multiple simulations with different environment settings using RoboMaker and train a single SageMaker model to build a super robust model that can work without this white paper, right? So what we saw, just to sum everything up, we saw how you could use RoboMaker and SageMaker together to build a very robust reinforcement learning model in the cloud. And that can transfer over to the physical world. Thank you.